Okay, algebra students, we're going to go ahead and talk some more about slope. We're going to talk about slope as rate of change. And so slope can look at like average rate of change in a problem. So when we're working with problems in context or kind of word problems, we can describe slope as rate of change or a rate or even as kind of like a speed. The most common graphs we see when dealing with rate of change is distance and time graphs. And so instead of an x-axis and a y-axis, our x-axis would be our distance, or our time, and our y-axis would be our distance. The formula that relates distance and time is d equals rt. And that formula is distance equals rate times time. And then what we can actually do is we can rearrange this. We can actually solve for r by dividing by t on both sides. And that cancels out those t's, and then we get this formula right here, where rate is the distance divided by time, which is actually kind of like a rise over run on our graph. And so whenever we do rise over run on a distance and time graph, we end up with a rate, or our slope. So again, when we're working with these types of graphs, time is usually our independent variable, so it's on our x-axis. And distance is usually our dependent variable because our distance depends on how long we've been traveling, and that's graphed on the y-axis. Depending on the situation, the rate may not always be the same, and therefore our graph may not be linear or look like a straight line. So not all tables will have common differences between the points, yet we can analyze the differences between each point in the data set, or analyze the differences between parts of the graph. So let's go ahead and look at a problem. We have a table that shows a truck driver's distance from home during one day's deliveries. Find the rate of change for each time interval. So we've done rate of change on tables before. We've done them several times, and so we can do kind of the same thing. And we can look at it again as this is our x and this is our y. And so when I'm looking from hour 0 to hour 1, I can look at, okay, how is this changing? So here I'm going 35. And here I'm going 1, and then my change of y over change in x would give me 35 over 1. So this is 35, and then I can use my units. So my distance for y is miles, and my distance for x is hours. So this is 35 miles per hour, and that's my rate. I could also do this using the slope formula. I could do 35 minus 0 over 1 minus 0, and that would give me the same rate. And so now we're going to go ahead and go to our 1 to 4, because that's where our table jumps from 1 to 4. So I can also look at, okay, from 35 to 71, that gives me 36. And then from 1 to 4, that gives me a change of 3. So 36 over 3 gives me an average speed of 12 miles per hour. So now from hours 4 to 5, I can do the same idea. So from 71 to 82 gives me 11, and 4 to 5 gives me 1. So this is 11 miles per hour. And keep in mind this is an average rate of speed, so in that hour, that's about his overall speed. So that may take into consideration stops and all that. It may not be his speed the entire time. It's just an average over that period of time. Okay, from hour 5 to 8, so from 82 to 199. So from 82 to 199, that's a change of about 117. And then from 5 to 8, that's a change of about 3 hours. So 117 divided by 3 gives us about 39 miles per hour. And then our last one, we're going to go from 8 to 10. So 199 to 200 is a change of 1. And then 8 to 10 is a change of 2. So this is 0.5 miles per hour. Okay, the rate of change represents average speed. during which time interval was the driver's average speed the least or the smallest? And that is obviously our hour 8 to 10. Because driving half a mile an hour, not very fast at all. Okay. So we've seen these type of graphs before. These graphs were our graphs from chapter 3. And we used them to talk about how far away from home was a boy, I can't remember his name, when he was running. So he'd run to school, or he'd start at school and he'd run. And so we're going to start looking at these a little bit closely as rate of change or average speed. And so kind of like the table where it broke down into parts, we're going to break down this graph into parts. And so we have one segment right here where we can actually calculate the speed. So that way, as we look at other graphs, we can kind of figure out what's happening. Now, our time is broken up into hours. And so I have 1 hour, and then I have 1/6, 1/3, 1/2. What these really are, these are 10-minute intervals. And so when I'm looking at this, I can really think of it in minutes if I want to, or I could think of it as parts of an hour. So when I'm looking at this first pink segment, when I want to do rise, I am going up 2.5 miles. And then when I go over, we're going over 1 mile. 1 hour. I apologize for that. So 2.5 miles in 1 hour. And so that was pretty easy. It tells us our speed right there. There's no real simplification. 2.5 miles per hour. But some of our problems are going to get a little bit more difficult. So now let's look at the second part of the graph. So we get this one. And we're obviously going towards home. So our speed itself is going to be looking at the absolute value. The sign, the negative, tells us the direction. So away or to. So when I'm looking at this, I'm going to do rise, which is 2.5 miles. And it's down, so it's negative. And then I'm going to run over, and I'm going from 1 to 1.5. So when I think about that, I'm really going over half an hour. And so this is where we start getting weird, because now I've got a fraction within a fraction. And we've dealt with these before. We've dealt with these before in math. They're really not all that bad. And we learned that when working with fractions, that dividing by a fraction is the same thing as multiplying by the reciprocal. So I'm going to take this negative 2.5, and instead of dividing by 1/2, I'm going to times by the flip of it. Which is really nice, because then I'm just taking the negative 2.5 and timesing by 2. So this is negative 5 miles per hour. So really my speed is 5 miles per hour. The negative just tells me the direction I'm going to. And so that allows me to see that this blue part is much steeper. In fact, we're going much faster. We're going 5 miles per hour. Where on the pink part, we are only going 2.5 miles per hour. And again, the sign was just telling us the direction. So let's look at our next graph. Let's look at the first part. So our rise is 2 miles. Our run is 1/3 hour. And remember, instead of dividing by the fraction, I'm going to times by the reciprocal. So this is going to be the same thing as 2 miles times 3/1, which gives us 6 miles per hour, which is the fastest we've seen so far. Okay, so now we're going to look at another part. Do a color we haven't done yet. So this portion, we would look at our rise. and our rise is 0. And our run is, let's see, I'm just going to go ahead and count parts. So 1, 2, 3, 4, 5. 5 parts is really 50 minutes out of 1 hour. So this is really, I'm traveling 5/6. So if I were to do my math, I would do 0 times, and I would flip 6/5, which doesn't really matter because 0 times anything is 0. So this is 0 miles per hour, which makes sense because when we look at it, it's flat. We're not moving anywhere in that amount of time. So this is 0 miles per hour. Okay, and the last portion, we're going to go ahead and look at this right portion. So we're going to do our rise, and it looks like from 2 to 4 miles, so 2 miles. Kind of running out of room here to write. And then I'm going to run 1, 2, 3, 4, so 40 minutes out of 60 minutes, which is really 2/3 of an hour. So this is going to be divided by 2/3. Okay, so I'm going to take 2 and I'm going to times by the reciprocal. And so now this is the first time where we're getting a fraction where it's not as nice. So remember with our fractions, we times the top. So 2 times 3 gives me 6. And then I divide by whatever's on the bottom. And 6 divided by 2 gives me 3. And so this is 3 miles per hour. Okay, so now we're going to go ahead and look at our next graph. Same idea. We have got a rise over run. So I am rising 2, and I'm running 20 minutes. So let's see, 2, and I'm dividing by the 20 minutes. Luckily, this is all mapped out. This is 1/3. So this turns into 2 times 3/1, which tells me that it's 6 miles per hour. Okay, now I'm going to move on to the red. And luckily, I learned from my last problem, and I also remember from the other day our notes that when it's flat across, the slope is 0, so this is 0 miles per hour. Woohoo, I like those kind of problems. And then we're going to go ahead and look at this green section right here. So this is going down, let's see, it's going down 2 miles. And then I'm going over 1, 2, 3, 4. So 40 minutes out of 60 minutes is really 2/3 of an hour. So I'm going to divide by 2/3. And then it's the same thing as timesing by 3/2. So this becomes -6/2, which becomes -3 miles per hour. And so our speed is 3 miles per hour, but the negative tells me my direction. Okay, let's go ahead and move on to our next one. This time, we're starting up high, and we're traveling down. So we're going to look at that pink part. It looks like we are going down 3. And then right 1, 2, 3, which is 30 minutes out of 60, which is half an hour. So -3 times, I flip. So this becomes -6 miles per hour. Okay, and then I move on to my next portion, which I love because it's flat, which already tells me that it's 0 miles per hour. And then we're going to look at our very last portion, which is going up. So we are going up from 3 to 6 miles, which is 3 miles. And then we're going over 1, 2, 3, 4, 5, 6. So that's 60 minutes out of 60 minutes, which is 1 hour, which is nice, 3 miles per hour. Okay, so that's pretty much using our graphs. We can use a table to calculate our rate. We can use graphs to calculate our rate. And it's all using that same stuff, that same idea of slope. So we're going to take one little spot to kind of look back at chapter 1. At chapter 1, we took equations and we solved for y. And we solved for y because when we came to chapter 4, we're going to start seeing that the number that we end up with in front of x actually ends up being our slope. So we're just going to review this really quick because we're going to keep using that throughout the chapter. So here, I have 2x plus 3y equals 12, and what I want to do is I want to solve for y. So I want y by itself. So the first thing I do is I move that x. So now I'm going to have 3y equals negative 2x plus 12. I'm now going to divide everything by 3 because I want to get rid of that y. And when I divide, I have to divide everything, which is why we usually save that for the very last step. So now I have y equals negative 2/3 x plus 4. And this is our slope. And so that's something that we wanted you to see because, again, we're going to be using it a lot this chapter. So on our next problem, we're going to move our x. So I'm going to minus 4x because it's a positive 4x. So now I'm left with, be careful, that's a negative 2y equals, and then I'm going to have my negative 4x and plus 16. Now keep in mind, these don't combine because one has an x and the other one does not. So they're not like terms, we can't combine them. Now I divide everything by negative 2 because that's the number I'm timesing by y, and I want y to be by itself. So the 2's cancel, the negatives cancel, and now I have y. Here my negatives cancel, 4 divided by 2 gives me 2, and 16 divided by negative 2 gives me negative 8. So now I have a slope of 2, or a rate of change of 2, or a speed of 2. So all things that we've seen that we're talking about, that we're reiterating over and over. Now our last one, we move our x, so I'm going to subtract 1x on both sides, keeping in mind that these are not like terms. So on this side, they do not combine. I now have 2y equals negative 1x plus 8. And now I have to divide everything by 2. That's why we save dividing step always for last if we can. Because if we end up with awful fractions, then we don't have to do anything else with them. So y equals negative 1/2 x plus 4. And so our slope is negative 1/2. And that's it for section 4.2. So I'll see you in class and we'll practice these concepts.